So in calculus, we have three big theorems. One we've already done. That's the intermediate value theorem. And we reviewed that not too long ago. But it's the one that says if f of x is continuous and you go from 5 to 12, then you had to hit every point in between 5 and 12. Now we're going to do the extreme value theorem. It is if f of x is continuous on some closed interval, then there exists an absolute max and an absolute min on that interval at either endpoint, so A, B, or any value on the open interval such that f prime of x equals 0 or f prime of x is undefined. That's basically, we just figured out the extreme value theorem. But this is the theorem that says what we just did is always going to be the case. Now, if it's not on a closed interval, so like the very first one we did, where it was none, that's because it was on the whole thing. But if I had said only from here to here, then there has to be an absolute max and a min. Now, you won't have to give me theorems. You'll just have to be able to apply these theorems. So the extreme value theorem, main thing, it's got to be continuous. And it's got to be on a closed interval. So you just got to make sure those two things happen. If it does, that means we have an absolute max or min somewhere. Okay. So for the next one, we're going to consider this cubic function to answer the following questions. Determine the intervals where f is increasing and decreasing and justify your answers. What do we have to do to tell if the graph is increasing or decreasing? The first derivative, that's right. This is what you would use to find maxes and mins, because you would know when things are increasing and decreasing. So we are going to find the first derivative. And how do I find the critical values where it changes, or the critical points? Yep, z equal to 0. So I'm going to solve this by factoring. Factor out -3 first. Two numbers that multiply to give me 3, but add to give me 4. Yep. 3 and 1. So there's our critical values. To figure out if it's increasing or decreasing, we just have to look around. And we're just going to plug those in to this. And just see if it's positive or negative. So I know -3 is just negative, so it's no big deal. Plug -4 into this one, I get a negative. And if I plug -4 into this one, I get a negative. 3 negatives times each other is a negative. Does that make sense? I'm not losing it. Okay. So over -2, -3 is negative. So that doesn't change anything. And then positive, and then negative. So this one's positive. And 0, negative, positive, positive. So, f of x is decreasing from -infinity to -3 and from -1 to infinity. And f of x is increasing from -3 to -1. I guess I should say y, just 5, because f prime of x is less than 0 here, then f prime of x is greater than 0 here. But you can't use the sign chart as a reason. It's there, it helps us figure out the reason, but you have to give the reason. You have to write it out. And you could have just said f prime of x is negative, or f prime of x is positive, but it doesn't matter. So what we're doing is we're doing this step by step. We're drawing it out. So on B, determine the coordinates of the relative extrema. So we just already did all that. So we know it goes from negative to positive at -3. So we have a relative, negative, positive, that would be a min, at x equals -3. But it wants to know the coordinates. So how do I find the other part? To f of x, right. I'm going to leave it blank for right now because f prime of x changes from negative to positive. So let's see. F of -3 is negative of -3 cubed minus 6 times -3 squared minus 9 times -3 plus 2. I'm plugging it in to f of x. So let's see, it's -27 times negative, so positive 27. 9 times -6, -54, plus 27, plus 2. Now that, all those 27s and 54 cancel out, so that's just 2. So your relative minimum is at -3, 2. And we have a relative maximum at, we're going to plug in, this time it's 1, no, -1. F of -1. it's negative 1 minus 6 plus 9 plus 2. Oh no, it's positive 1. So it's negative 5 plus 9 is 14. No, plus 9 is 4, plus 2 is 6. There we go. Good? Okay. And again, we have to put the because f prime of x changes this time from positive to negative. Okay, so this function is pictured here. But it's only pictured from negative 4 to 1, so on a closed interval. We're going to find the absolute maximum on this closed interval, so just on the picture. Wait a minute. What's the absolute maximum?
-4, 6, and -1, 6.
Yeah. Notice one of those was our relative max of negative 1, 6. Same thing. Now we're doing absolute minimum. So what's that?
1/14. Is it asking the same thing? That's what I was
Yes, and the answers here are,
Did it mean to say like relative?
yeah, nah, it should have said, I'll switch them down here. It's fine. So now on these, we'll do relative. Okay, so what's, according to the picture, what's the relative maximum? Yeah. And the relative minimum. And notice that relative minimum is the same thing we found up here.
If there are 2, can I put the union on it? Or
Can you put the what?
like the union, the little U?
Union, no. Because that means you're including 2 intervals. These aren't intervals, these are points. Good question. What time is bell ring for this class? Okay, we'll stop there since it's a great place to stop. And we got through so much more than we would normally get there. But granted, there was just one person. Miss all y'all.